Okay, let's still have a few final words on measures of central tendency. And one aspect is that the relationship between the mean and the median can be used in order to gauge whether a distribution is skewed to the right or skewed to the left. So to illustrate this, just assume that we start with a symmetrical curve, like a nice normally shaped or bell-shaped curve. If that is the case, the mean is equal to the median and the mode. So think about it, for example, the distribution of homes in a city. So some of them are very poor, let's say some poor households, and the houses are not very expensive, and others are very rich, they have like very expensive homes. But there is like a healthy middle, and the distribution of home prices is normally distributed. So now assume that the superstar moves into your neighborhood and builds a mansion which is like a multi-million-dollar expensive home. So what will happen now, if we start with a distribution which is normally distributed, that will not necessarily affect the median price, because the middle point is probably still the same. But what happens is it will pull up the mean substantially. So whenever the mean mu is greater than the median, then the distribution is skewed to the right. So important is really the mean greater than the median. Whenever the mean is greater than the median, that is a clear indicator that the distribution is skewed to the right. And that's probably the case for like something with home prices, GDP per capita. A lot of data in the social sciences is actually skewed to the right. But we can also imagine a distribution which is skewed to the left, and unfortunately we don't really see them that often, at least in economics, because it's much easier to correct for a distribution and to make it more normal when it is skewed to the right. If something is skewed to the left, then we cannot really have something like a log transformation that will make it look more normal. But anyhow, so again, if you, let's say, start with a normal distribution, and suddenly something enters that distribution which has a very, very low value, well, that may pull down the mean below the median. So whenever the mean is less than the median, the distribution is skewed to the left. So an example for a distribution which is skewed to the left is, for example, if you imagine the distribution of pilots that can fly a very sophisticated airplane like the old Boeing 747 or the Airbus 380. So normally you have to go through a long career as a pilot before you can fly those high-end airplanes. So most of the pilots are probably quite old, but there may be some superstar pilots that are very, very young. And when they enter the distribution of pilots, they may pull down the mean and skew the distribution to the left. So, but anyhow, to make a long story short, whenever the mean is greater than the median, that's a clear indicator that there are some outliers. Whenever the mean is below the median, then it is skewed to the left, and we have the outliers and the low end. And the mean is equal to the median and the mode when we have a nice symmetric distribution. So a final word now, I still want to say something on when is it best to use the mean, the mode, or the median to describe data. So when the mean is the mathematically most accurate descriptive summary statistics. And this is because the sum of all differences to the arithmetic mean is 0. So let me illustrate that using an example. So let's say we have 3 observations. I get all of here. So I keep it simple. We have 3 observations. So I, 1, 2, 3. And let's say we look at the age of certain kids. Let's say one child is 2, the other one has an age of 3, and the other one is, let's say, 10. So in this case, the mean is equal to 2, 5, 15 is 5. So in this case, we will say the mean is 5. So now when we say the sum of all differences to the arithmetic mean is 0, just consider what happens if we add another column and we subtract from each observation the mean. So xi minus the mean of 5. So then we have 2 minus 5. That's negative 3. Then 3 minus 5, negative 2. 5 minus 5, positive 5. So you see those differences, negative 3 plus negative 2 is negative 5 plus 5. Those differences are equal to 0. So in other words, we can write that the sum of all the observations minus the mean, that is always equal to 0. And that is what makes the mean the mathematically most accurate measure of central tendency. The median is obviously not, or the deviations from the sum of all the deviations from the median are not equal to 0. So what is the median here? So we have 3 observations. So the index number would 1.5. So we have to round up. So the median is 3. And if you subtract from each observation the median, then so then if we did this one here, so if we did xi minus the median, then we have 2 minus 3, negative 1, 3 minus 3 is 0, 10 minus 3 is 7. So in this case, the total deviations from the median is negative 1 plus 7, total 6. So in this case, because the mean was 5 and it is greater than the median, we would conclude that the distribution is actually skewed to the right. So, but anyhow, I think that the concept is clear what we mean by the mathematically most accurate. The mathematically most accurate measure of central tendency relates to the fact that the sum of all the deviations from the mean are always 0. That makes the mean the mathematically most accurate. But sometimes we still need to know the median. So for example, in economics we like to report the median income or the median household income rather than the average household income. So in most advanced economies around the world, and maybe also in some developing economies, the average household income is typically greater than the median income. But that might be because of tremendous income inequality. So we'd like to report the median whenever we suspect that the distribution is highly skewed, and especially skewed, doesn't matter which direction. Most of the data in economics is skewed to the right. So when we report the median, then in light of a distribution which is, highly skewed, the median becomes the more representative measure of central tendency. It just captures better the majority of the people living under a certain value or with a certain value. So in sum, when the mathematically most accurate descriptive summary statistic is needed, the mean is the best choice. And this is again, the sum of all differences to the arithmetic mean is 0. That's what I try to illustrate here. But when we ask what is the most real-world relevant descriptive summary statistic, the most representative, and especially when outliers skew the distribution, then the median is the best choice. And last but not least, when we ask the question, what is the most popular, the one that is most sold, the most cited, things like this, then we use the mode. Okay, so I hope that makes clear when to use the mean, the mode, or the median. Mathematically, the best measure of central tendency is the mean. The median is the most representative value. And the median is typically reported whenever the distribution is not normal. And last but not least, the mode is simply the most frequent observation. Okay, so that concludes everything about the measures of central tendency. And beginning with the next video, let's start talking about measures of dispersion.